Hi, everybody. It's Professor Mitchell. We have reached the last section of Chapter 5, which is 5.6 on dividing polynomials. In this section, we will divide a polynomial by a monomial, and then we'll use long division to divide a polynomial by another polynomial. And as through this entire chapter, we're doing SLOA, which is to perform mathematical operations on algebraic expressions. All right, so first we'll talk about dividing a polynomial by a monomial, which, like it says, if I show you the examples, we're just going to take each of these fractions and break them up into smaller fractions so that we divide each term of the polynomial on top by the monomial on the bottom. So let me switch over to the tablet and I will show you how that works. Starting with 6x to the fifth plus 3x to the fourth, all over 3x to the fourth. All right, so we're just going to break this into two smaller fractions, each with denominator 3x to the fourth, and the separate terms in the numerators. And then to simplify each of those smaller fractions, you just use the rules that we went over in sections 5.1 and 5.5 on simplifying expressions with exponents. 6x to the fifth divided by 3x to the fourth is 2x. And of course, 3x to the fourth divided by itself is 1. All right, so that one comes out to have a nice answer. Sometimes there will be a fraction in the answer, like in this one. So we're going to start this one the same way. We're going to make two fractions, each with denominator 7m. Numerators will be 14m squared and 27m cubed with a minus in between. 14m squared divided by 7m is 2m. And then 27 over 7, I can't simplify that, so I just leave it as 27 over 7. M cubed divided by m is m squared. All right, and finally, we have 6a squared minus 4a plus 12 all over negative 2a squared. So one more time, this time we're going to make three fractions, each with denominator negative 2a squared. And the numerators are going to be 6a squared minus 4a plus 12. All right, 6a squared divided by negative 2a squared is negative 3. All right, now with this one, I have to be careful. 4 divided by negative 2 is negative 2. And then a divided by a squared leaves a on the bottom. Okay. And then finally, 12 divided by negative 2 is negative 6. And we just leave a squared on the bottom. All right, so the only other thing I would do with this would be to rewrite it so I don't have the parentheses. So instead of subtracting a negative, we'll just add 2a. And then here we'll make this one minus 6 over a squared. All right, and that is the idea behind dividing by a monomial. So now let's look at dividing a polynomial by a polynomial. All right, so I like to start this by talking about long division of numbers. So here's an example that I found on Google Images, 4 into 435. So hopefully you remember the process, how that works. Step 1 is divide 4 into 4, which leaves 1. Step 2 is multiply 1 times 4 is 4. Step 3 is subtract. 4 minus 4 is 0. And then bring down the 3 and repeat those 3 steps. So it's divide, multiply, subtract. Divide, multiply, subtract. When you get your answer, in this case, 435 divided by 4 equals 108, which is called the quotient, plus 3/4. 3 is the remainder. All right, so it turns out that you can also do this with polynomials. Given two polynomials, n of x and d of x, so I picked those names to mean numerator and denominator. There exist polynomials q of x and r of x, as in quotient and remainder, so that you can write n of x divided by d of x as the quotient. So this q of x is sort of taking the place of the 108, plus the remainder taking the place of 3 over the divisor, which is taking the place of 4. And I should also mention one other thing, which I don't have written down here. In this long division problem, not any old number can be the remainder, right? Since we're dividing by 4, the remainder would have to be either 0, 1, 2, or 3. It would have to be a non-negative number that is less than the divisor, 4. So the polynomial version of that is that the remainder polynomial has to have degree less than the degree of the divisor. All right, and I'll say that again a couple times as we're doing our examples. Okay, so it says, put down your pencil and watch. You'll have plenty of time to write it down afterwards. Well, of course, if you're watching a video, you can pause the video whenever you want. But I encourage you to do that. Just watch me do the problem. And then when I'm finished with the problem, I'll tell you that I'm finished. And then at that point, you can pause the video and take good notes. All right, so we have 3 examples. Let me switch over to the tablet. The first example is 3x squared plus 8x plus 4 divided by x plus 2. So again, put down your pencil. The way we set this up is we write x plus 2 outside. That's the divisor. We write 3x squared plus 8x plus 4 inside. That's called the dividend. All right. So step 1 is divide. Divide x into 3x squared. 3x squared divided by x is 3x. So I'm going to write 3x up here. Step 2 is multiply. Remember, it's divide, multiply, subtract. 3x times x is 3x squared. 3x times 2 is 6x. Okay. So now we're on to step 3, which is subtract. And when you're doing polynomial long division, you have to make sure you subtract the whole thing. Okay. 3x squared minus 3x squared cancels. This first pair of terms should always cancel. 8x minus 6x is 2x. So I'm going to put that 2x here. And then I'm going to bring down the 4. All right, so that is one cycle of divide, multiply, subtract. So now I'm going to do it all over again. This time I'm going to divide x into 2x. X into 2x goes 2. 2x divided by x is 2. 2 times x is 2x. And 2 times 2 is 4. Okay. Step 3, subtract. We subtract the whole thing. 2x minus 2x cancels. And in this case, 4 minus 4 is 0. So the remainder is 0. All right. So again, you write your answer in the form quotient plus remainder over divisor. So in general, I would write this answer as 3x plus 2, which is the quotient, plus the remainder, which is 0, over the divisor, which is x plus 2. When the remainder is 0, you can leave out that fractional term because any fraction with 0 as the numerator is 0. So in this case, the simpler answer would be 3x plus 2. All right, so hopefully you were watching that and not writing. So at this point, please pause the video and take all the notes you need. And when you're ready, we'll go on to letter B. All right, here we go. So we're going to start off kind of the same way. 2x plus 3 is the divisor. Okay, now I need to be careful in this one because notice that the terms in the dividend are not written in descending order of powers. I have a squared term and then I have a cubed term. Make sure you put the cubed term first. Both the divisor and the dividend need to be written in descending order. All right, so again, the first step is divide. We're dividing 2x into 4x cubed. 4x cubed divided by 2x is 2x squared. So that goes up here. 2x squared times 2x is 4x cubed. 2x squared times 3 is 6x squared. Subtract the whole thing. All right, so 4x cubed minus 4x cubed cancels. 12x squared minus 6x squared gives me 6x squared. And then I like to bring down all the remaining terms just so I don't lose track of them. Technically, you only have to bring down the next term, but that's the way I like to do it. All right, so that is one full cycle of divide, multiply, subtract. So now I do it again. This time I start by dividing 2x into 6x squared. 6x squared divided by 2x is 3x. 3x times 2x is 6x squared. 3x times 3 is 9x. Subtract the whole thing. 6x squared minus 6x squared cancels. X minus 9x is negative 8x. Bring down minus 14. All right, so we're going to do this one more time. In just a second, I'm going to share with you a little trick that will tell you how do you know when you're on the last cycle. This time I'm going to divide 2x into negative 8x. Negative 8x divided by 2x is minus 4, which is a constant. As soon as you see a constant up in the quotient, that means you're on the last cycle. So let's see. 2x into negative 8x goes negative 4. Negative 4 times 2x is negative 8x. Negative 4 times 3 is negative 12. Subtract the whole thing. Negative 8x plus 8x cancels. Negative 14 plus 12 is negative 2. So the answer, which again has the form quotient plus remainder over divisor, would be the quotient, which is 12x squared plus 3x minus 4, plus the remainder, which is negative 2, over the divisor, which is 2x plus 3. All right, and that's going to be my answer. All right, one last example. This one, I think I need to show you how to set up, and then maybe once I've set it up, pause the video and try this one. So what's special about this one is that in the dividend, x cubed plus 64, you have a bunch of missing terms. We're missing an x squared term and we're missing an x term. So what you need to do in that situation is put in some placeholders. I'm going to put a 0x squared, and then I'm going to put a 0x. Okay, so pause the video and try this one, then come back and compare notes. All right, x cubed divided by x is x squared. X squared times x is x cubed. X squared times 4 is 4x squared. Notice that the columns underneath the division problem are always lined up by like terms. That's one of the reasons that we put placeholders there. Otherwise, that wouldn't happen. Subtract the whole thing. X cubed minus x cubed cancels. 0x squared minus 4x squared is minus 4x squared. Bring down the remaining terms. All right, that's one cycle. Let's start the next cycle. X into minus 4x squared goes minus 4x. Minus 4x times x is minus 4x squared. Minus 4x times 4 is minus 16x. Subtract the whole thing. Negative 4x squared plus 4x squared cancels. 0x plus 16x is 16x. Bring down 64. All right. Next, we go x into 16x, which goes 16. There's my constant, so we're on the last cycle. 16 times x is 16x. 16 times 4 is 64. Subtract the whole thing. So not only do these terms cancel, but 64 minus 64 is 0. This one has a 0 remainder, which means the answer is just the quotient, x squared minus 4x plus 16. All right, so the last part of this video, I'm actually bringing this in from section 5.7 as an optional shortcut for certain polynomial division problems, and that's called synthetic division. Synthetic division can be used whenever the divisor has the form x minus c. And when I say x minus c, I mean not only things like x minus 2 or x minus 4, but even something like x plus 3, which you would think of as x minus negative 3. All right, so I'm getting ready to show you how this works as soon as I can find my mouse again. There we go. All right, so here are the examples that I will show you. A lot of people find synthetic division to be a little confusing at first, but I think once you get used to it, you'll be hooked. I always use this whenever I can. Again, you can only use it when the divisor has this form. In other words, the leading term of the dividend has to be x. It can't be 2x. It can't be x squared. It has to be x. All right, so switching over to the tablet. Get ready to watch, don't write. All right, so the idea behind synthetic division is to eliminate a lot of repetitive and unnecessary writing. So the first thing is that the x minus 1 as the divisor, we just write that as a 1. That 1 stands for x minus 1. And then we make this different sort of division bar. And then 3x squared minus x minus 4, we just take the coefficients, which are 3, -1, and -4. Okay. And then the cycle for synthetic division just has two things once we get going. We're going to start by bringing down the 3. And then we're going to do just two things on a loop. We're going to multiply by 1, which represents our divisor, and put that answer here. And then we're going to add. add going down. So -1 plus 3 is 2. And then just repeat, 1 times 2 is 2. -4 plus 2 is -2. And I'm just writing all these arrows because it's the first time you're seeing it. Once we get into practice, I won't write the arrows. This -2 is the remainder. And then the 3 and the 2 represent the coefficients of the quotient. The 2 represents the constant term 2, and the 3 represents the degree 1 term 3x. So this means that the answer to this division problem is 3x plus 2 plus -2 over the divisor, which is x minus 1. So hopefully you have just been watching and not writing. So now please feel free to take all the notes you want. And when you're ready, we will go on to the next example. All right, the next example is 4x cubed plus 11x squared minus 8x minus 10 divided by x plus 3. So the first thing you have to be careful of with this one, we're going to think of that x plus 3 as x minus -3. And we're going to put a -3 outside. All right, and then the coefficients of the quotient are, of the dividend, I'm sorry, are 4, 11, -8, -10. All right, so once again, we start by bringing down the first term, 4, and then we go -3 times 4 is -12. 11 plus -12 is -1. -3 times -1 is 3. -8 plus 3 is -5. -3 times -5 is 15. -10 plus 15 is 5. So again, this is your remainder. Reading from right to left, you have your constant term, your x term, and your x squared term. So the answer for this division problem is 4x squared minus x minus 5 plus 5 over x plus 3. All right, so again, this is optional. If you feel like you don't really like this so far, just give it a chance. All right, it's a little confusing at first. It's a shortcut. It's gimmicky, but once you get used to it, again, I think you'll be hooked. All right, one last example, and this is very important. Not only do we have to remember to put a -4 to represent x plus 4, but this dividend is missing an x squared term. So for synthetic division, you absolutely have to put the placeholder. Otherwise, you will get the wrong answer. I'm having trouble writing that there. All right. So 3, 0 stands for 0x squared, 11, and then 12. All right. So one more time, we bring down the 3. -4 times 3 is -12. 0 plus -12 is -12. -4 times -12 is 48. 11 plus 48 is 59. -4 times 59 is -236. 12 plus -236 is -224. So we have our remainder. We have our constant term, our degree 1, our degree 2. So the answer is going to be 3x squared minus 12x plus 59 plus -224 over x plus 4. All right, and that's going to do it for section 5.6. That's going to do it for chapter 5. We'll see you next time.